Good morning, everyone. It is Tuesday, the 16th of March. So today we're going to look at the relationship between meters and kilometers. So similar to yesterday's concepts in which we focused on meters and centimeters. So today's meters and kilometers. The learning objectives are that you're able to record measurements using decimal notation, that you can convert lengths using different units of measurement, and that you can compare and order lengths. Okay, so to begin, we're going to look at some revision questions. So I want you to pause the video now before I get through the answers. Okay, so the first one is multiplication sum. 3 3s are 9, 3 5s are 15, so put down your 5, carry your 1, 3 2s are 6, add your 1 is 7, 759. 4 into 3 doesn't go, 4 into 30 goes 7 times, remainder 2, 4 into 24 goes 6 times. Okay, so type of triangle. Okay, so you can see that this side and this side are the same length, so it's two sides the same length. It's not a right angle triangle, it's not an equilateral triangle because only two sides the same length. It's not a scalene because it has two sides the same length, so it is an isosceles triangle. Okay, next question. At 9 a.m. there were 812 cars in a car park. By 10 a.m. 37 cars had left the car park. And so we'll work out that calculation first. So 812 take away 37. So 8, 1, 2, take away 37. So 2 take away 7 you can't do, so you have to borrow this. 12 take away 7 is 5. 0 take away 3 you can't do. So 10 take away 3 is 7. And 7 take away nothing. So 775. That's by 10 a.m. Then it says another 151 cars into the car park. So there was 775 plus 151. So if you add the 50, it would bring you up to 825. Add the 1, 826. Then add the 100, 926. So 926 is your answer. Okay, tick the two shapes that have 2/3 shaded. So you need to be really careful that you count how many parts are in each specific shape. So the first shape has 10 parts and 5 are shaded in, so that's a half, so that is not 2/3. The next shape has, well, you can clearly see without counting that 2/3 are shaded, so that shows 2/3. The next shape has 9 squares, 6 are shaded, so 6 over 9 is the equivalent of 2/3, so that is correct. And the next one has 20 squares and 14 are shaded, so 14 over 20 is not 2/3, and 20 can't be divided by 3 equally anyway. So now we're going to look at how to write lengths in different ways, okay? So this slide is very similar to the slide in yesterday's work. And again, just a simple fact to start us off, 1,000 meters equals 1 kilometer. And if we look at the distance here, it says 1 kilometer, 342 meters, is in total meters 1,342, and then decimal form is 1.342 kilometers. Okay, and just emphasizing that your answer then is in kilometers. Okay, so 2 kilometers 59 meters. So remember this, 2 kilometers is 2,000. Okay, 2,000 meters, and add 59 to that, and you've got 2,059. So it's not 2,590. In decimal form then it's 2.059, again because you think this is 2,000, this is hundreds, and there are no hundreds, this is 5 tens, and this is 9 units, so it gives you 59. So 0 kilometers 445 meters is 445 meters in total. Okay, and then in decimal form, because there isn't a full kilometer, so it's 0.445 kilometers. Finally then, 5 kilometers 900 meters in total meters, it is 5,900, and then 5.9 kilometers. Right, so we're just going to use the information that was included in the previous slide to help us answer these questions, okay? So in each question is asking you to write down your answer in meters, okay? So if I look at A, for example, so what is A in meters? A in meters is 2,000 meters, okay? Because 2 kilometers is 2,000 meters, okay? 5 kilometers in, 5,000 meters. 3.5 kilometers, well, you know 3 kilometers is 3,000. Half a kilometer is 500, so it's 3,500 meters. Okay, and I'll complete D then. D is 3/10 of a kilometer, so 1/10 of a kilometer is 100 meters. So 3/10 is going to be 300 meters. Okay, so just be careful when you're moving in from kilometers to meters, okay? So just remember 3/10 of a kilometer is not a full kilometer, okay? So your answer is going to be less than 1,000. Okay, so I would like you to pause the video now, and I would like you to complete E all the way through to L in your jotters. Okay, good luck. Okay, so if I look at E, E is 4 kilometers, 300 meters, in meters only, that is 4,300 meters, okay? In decimal form, it would be 4.3 kilometers. F then is 2 and 1/10 kilometers, so 2 kilometers is 2,000. 1/10 of a kilometer is 100 meters, so it's 2,100 meters. G, 3 kilometers, 230 meters, so 3 kilometers, 3,000. Add the 230, 3,230 meters. H, 1 and 1/4 kilometer, so a kilometer is 1,000. Quarter of a kilometer is 250, 1,250 meters. Okay, I is 1 and 8/10 of a kilometer, so 8/10 of a kilometer is 800, so it's 1,800 meters. J, 1 kilometer, so it's just 1,000 plus 507, 1,507 meters. K, 9/10 of a kilometer, so it's in meters, 900 meters. L then, 5 kilometers, 342, so it's 5,342. Oh, forgot the 5. 5,342 meters. Okay, now if you were trying to convert any of these into kilometers only using a decimal, for example, E would be 4.3 km. I would be 1.8 kilometers. If I look at F, it would be 2.1. Okay, so it's important that you know how to do that as well. Okay, so now we're going to look at some further examples of changing distances into, for the first example, it's kilometers and meters, okay? So the first one is 2,168 meters. And if I was to move that into kilometers and meters, so the 2 represents 2,000, which is 2 kilometers, 2,000 meters, so it's 2 kilometers, 168 meters. Okay, and the next one, kilometers and meters, so 1,820 is 1 kilometer, 820 meters, okay, because we have to give a mix. Okay, so now I would like you to pause the video because I would like you to complete C and D now in your jotters. Okay, so C, 3,004 meters in kilometers, that is 3 kilometers and just 4 meters. And D, 7,060 meters is, if I have room to write this in, yeah, 7 km, 60 meters. Okay, so now we're going to look at some examples where it's writing it in kilometers only, okay? So A is a very easy example. So 7,000 meters is 7 km. B, 5,000 meters is 5 km. Okay, so the next two are a little bit more difficult, and if you can think of the previous examples that I went through on the other slide, in which I used decimals, these answers here will require you to use a decimal because you're writing your answer only in kilometres, okay? So I'd like you to pause the video now and to have a go at that in your jotters. Okay, so C, 2,500 metres, you've got 2.5 km. 8,700 metres, 8.7 km. Okay, hopefully you got those correct. Okay, so now we're going to look at a little problem solving task based on finding answers in metres, okay? And we're looking for the shortest distance between two places, okay? So if we look at the first question, it says Amberley to Enfield, okay? So there's two different ways. You could go from here to Dudley and then across to Enfield, or alternatively you could go from Amberley to Benton, then down to Enfield there. Okay, so we need to work out the two totals and work out which one is the shortest. So if I work out the blue route first, so it says 2.25 kilometres, so in metres, because we expected to answer metres, I'm going to convert that into metres. So that's 2,250 metres for the first part of the journey. And then from Benton to Enfield is 1 kilometre, so you're just adding 1,000 to that. So the total for that then is 3,250 metres. Okay, so if I look at the other journey now, the one that was in the black line, so it was, the first is 1 kilometre, which is 1,000 metres. And the second part is 3 kilometres, which is 3,000 metres. Very easy, add the two of them together, 4,000 metres. So which one, the shortest distance then was this one, 3,250. Okay, now I'm going to look at another example. So I'm going to look at B, and B is the distance between Benton and Fenwick. Okay, I'm just rubbing this out, so give myself some space. So Benton and Fenwick, so again, two possible routes. So I'll do a red one. So to get to Benton to Fenwick, I could go from Benton to Enfield, and then from Enfield to Fenwick. Or I could go from Benton to Carfell, and from Carfell to Fenwick. Okay, so which one is the shortest? So I'm going to work out the red journey first of all. So it's 1 kilometre. It's easy, 1,000 metres. So 1,000 metres, and then from Enfield to Fenwick is 2 1/10 kilometres. So 2 kilometres, 2,000 metres, plus your 1/10 is 100. So 2,100 metres. Add those two distances up, 3,100 metres for the red journey. The green journey then, the first one is 1 3/4 kilometres. 3/4 of a kilometre, 750 metres. Add the 1,000 to it, 1,750 metres. And the next part then is 1 1/4 kilometre. So again, that's 1,000 1/4 kilometres, 250 metres. So add those two up, and I get 3,000 metres. So the shortest distance is the green one. Okay, so now I would like you to go through exactly the same process to work out the answers to C and D on your own. Okay, good luck. Okay, now so from shortest distance between Dudley and Carfell. So if you see the other one here, so Dudley is here, Carfell is over there. So I could go Dudley, Enfield, Fenwick, Carfell. Okay. So Dudley to Enfield is 3 kilometres, which is 3,000 metres. Add 2,100 to it, so it's 5,100. Add the 1,250, so it's 6,350 for the first journey, okay, the yellow one. Okay, now you may have noticed in this one there's more than one route, okay? So if I choose a different route, say I go from Dudley to Amberley, and then from Amberley to Benton, and then over to Carfell, so I'll work out that distance. So that is 1,450 plus 2,250, so that's 3,650. I'm going to write this down just so I don't make a mistake. So 3,650 metres plus 1,750 metres. And add this up, so I get, so 0 plus 0 is 0, 5 plus 5 is 10, put your 1 over here, 6 plus 1 plus 7 is 14, and 5,400. Okay, now there is another possible journey. Okay, so that's the black route is 5,400. So far it's the shortest. You could also go another way. Okay, so if I do this in red, you could go from Dudley to Enfield to Benton to Carfell. So we'll work out the distance for that. So from Dudley to Enfield is 3 kilometres. Then it is, let's see, just cover that up. Then it is 1 kilometre to Benton, that's 4 kilometres. Then add on the 1 3/4, 5 kilometres, 750. Okay, so the red one's 5,750. Which means that our black journey is the shortest. So the one from Dudley to Amberley to Carfell, and that was a total of 5,400. Okay, so now we're going to look at the last distance, which is between Amberley and Fenwick. You can see that C was a little bit more difficult than the previous two because there was a few more steps involved and different routes as well, a larger number of routes. So from between Amberley and Fenwick, so Amberley is over here, Fenwick in the top left, Fenwick in the bottom right. So if I use black colour first of all, so I could go Amberley to Dudley to Enfield to Fenwick, so we'll work that one out first. So the first one is 1 kilometre. The next distance in is 3 kilometres, that's 4 kilometres and 2 1/10. So the first distance, the black one, is 6,000. So 6 kilometres, 100 metres, 6,100 metres. Then if I choose a different colour, so if I go from Amberley to Benton to Carfell to Fenwick, so a green route, so the first part is 2,250 plus 1,750 is 4,000 metres. Then add on 1 kilometre, 5,250. Then if I choose another route, so if I choose a red route, I could go Amberley, Benton, Enfield, Fenwick, and I'll work out that. So 2,250, then add the 1 kilometre, 3,150, or sorry, 3,250, then 2,100, so 3,150 plus 2,100 is 5,000, what colour am I using here? 5,350 metres. Okay, so your shortest distance there was the green route of 5,250.